So our second video today is going to be multiplying radicals. It's a little different of what you're going to do than adding and subtracting. So read the rules. Remember, y'all got where you can read the rules. So number one, we're going to multiply the coefficients. Remember, the coefficient is the number outside of the radical. And we're going to multiply coefficients first. Step two, multiply the radicands using the product rule. So the square root of A times square root of B would be square root of AB. Now, if we can simplify, we must try that. But obviously, remember, we can multiply anything. We can't add and subtract anything. So think about, just think about that being A times B. If I ask y'all what A times B is, you would say AB. Same rule applies. So square root of A times square root of B, square root of AB.
I always like to think it's easier to say outside times outside, inside times inside.
That's how we used to teach it, actually. All right, and then number 3 says simplify the resulting radical. Okay, the reason we do this a little backwards is because there's no reason to simplify the radicals, multiply everything, and then have to simplify again. So we just go ahead and quickly multiply and then simplify the answer.
We go to 2 steps rather than 3 steps.
Yeah. All right, we're going to do number 1, example. So square root of 8, Ms. Delk's going to go, all right, square root of 8 can be simplified. And remember that invisible 1 in front of there. So the square root of 8 breaks into, oh shoot, what am I doing?
We're not simplifying. Ignore her.
Lord, ignore me today. Had a long one.
Outside times outside. Inside times inside.
Woo, hello.
Ignore her.
Goodness. So look what Ms. Delk did. 1 times negative 3 would be negative 3. Square root of 8 times square root of 2, square root of 16.
Hopefully y'all know the square root of 16 simplifies to a perfect square root, and it is 4. So we then have negative 3 times 4, which would give us a negative 12.
See how easy that is? Now, they all will not perfectly do that.
No, for example, number 2 won't. Real quick, I'll show you.
Yeah.
Outside times outside.
Times negative 1.
Would be a negative 1. I'll put it there for now. Inside times inside, that'd be 3 times 2, which is 6. If I try to break down 6, I get 2 and 3.
It won't break.
Not enough to go on a date. So my final answer would be negative square root of 6.
See how easy that is? Okay.
Okay, let's do one with variables. Let's do this one.
6 is good.
Super easy. Outside times outside, inside times inside. So I've got negative 5 times 3, that's negative 15. Inside times inside, I would have 20x times 15x.
20 times 15, I haven't thought about that mistake.
No, we haven't thought of that, have we?
300? 20
Yes.
times 10 is 200. 20 times 5 is 100, so 300.
And then x squared.
And x squared.
Okay, 300. Obviously, that breaks down into 20 and 15.
Yeah, do you see what she's using? She's kind of cheating. She knows what she multiplied to get it, so she's going to use 20 and 15. That's how we used to, I would think about it like that. What you just used to get it. Just use those numbers. Simple math. Don't work too hard for this. Hey, she broke 15 and 20 to her prime factorization.
Made a Christmas tree out of it.
Okay, so negative 15 is already on a date.
So I'm going to bring it outside.
And then, let's see, 2 has a date. They're going to get together, go out on a date. 5 has a date.
The x's have a date.
And then who's left at home at all that? 3.
3.
Okay. So she's just going to simplify.
So that would be negative 15 times 10, negative 150.
X.
It is snowing outside.
Times square root of 3.
Mr. Ember is excited. He's from Michigan. Okay, we're going to show you another one real quick. This one you got to be careful because look, we got to follow those order of operations. Order of operations says that we must do multiplication before we could do addition. So I'm going to go ahead and bring this on down.
So 7x cubed square root of
6.
6. And we're going to multiply.
These are being multiplied. So outside times outside, that'd be a plus 1.
Inside
times inside.
24x to the 6.
Okay, and then I'm going to break it down. 8 and 3.
She could have used 12 and 2. Remember, what she just used to get there. But 8 and 3 is easier.
So the first one popped in.
Remember, she's got 6 x's over there. Okay, here we go.
Okay, they need to make these bigger for people like me. So we have 7x to the third radical 6.
Miss Dale did not simplify that because remember 6 is not its prime already. Like you
Yep,
can't
I can't
break
break
it. 2 and
down
3.
6. Okay, there's a 1 out in front, which won't really matter. I'm going to bring out this 2. I'm going to bring out one group of x's. I'm going to bring out another group of x's and a third group of x's. 2 and 3 were stuck at home. So I've got 7x cubed radical 6 plus 2x cubed radical 6.
Oh,
Those
there.
are like terms.
Look at those 7x cubed and 2x cubed you would put together.
So that would be
radical 6, radical 6. They look alike, so we can add the terms. So look at that answer. It'd be 9x cubed square root of 6.
very true.
Okay, not too bad.
Okay,
Just a little bit of work to get there. All right, on the back, they've got 2 examples for us. We're going to do those with you.
we're going to do distributive property. Outside times outside, inside times inside.
Can't mess it up.
Okay, so right here, I've got square root of 6 times 3. That would be 1 times 3, which is 3. This one does not have a radical, so I bring the radical along. There was nothing for me to multiply inside with. And do it again. I've got 1 times 1, which is a 1. I'm not going to put it. 6 times 8 would give me 48. We went from multiplying to now addition. Remember from the last video, to add, you must simplify the radicals. 6 is already simplified. No one will go on a date there. 48, of course, breaks down into 6 and 8.
She just did that math, so we're going to use the numbers we used.
2 and 3. 8 breaks down into 4 and 2. 4 breaks down into 2 and 2.
All right.
And of course, I don't have enough room. So I've got 3 radical 6 plus
All right, who's got some dates? 2's got
2's
a date.
got a date. Another
2's
2.
got a date. And then looks like 3's staying home tonight. Doesn't have a date.
So I've got 3 radical 6 plus 4 radical 3. Those are not like terms. So I have to leave it as this.
Okay, that's like the radical 6 family and the radical 3 family. They don't look alike, so they can't go together.
Notice that you had to go from here to this point, though, because you always had to simplify radicals. These were not like terms, but I cannot leave it because that one was not simplified. Okay, so that's where we're distributing. Now we're going to be foiling. So first times first. 4 times 2, that one was easy as 8. Outsides, that would be 4 times a negative square root of 3, so that'd be negative 4 square root of 3. Insides, that would be square root of 3 times 2, so plus 2 radical 3. Last, square root of 3 times a negative square root of 3, that'd be a negative square root of 9. Okay, now we're simplifying. I need to, in order to add or subtract, they must be alike and they must be simplified. 8, of course, is already simplified. I can't break down 3 because it's prime. But the square root of 9 is a 3. So now I've got 8 minus 4 radical 3 plus 2 radical 3 minus 3. Combining like terms. 8 minus 3 is 5.
Those are both constants.
Yep. Like radicals because they have the same index with the same radicand, so I can put them together. If I had negative 4 and I added 2, I would then have a negative 2 radical 3. Final answer.
All right, notice it's one of the few times in math we put the constant out front. Okay, because if you put it back here, you kind of don't know if it's meant to be under the radical or not. So we leave the constants out front, like in quadratic formula. We're going to kind of look at that. That's what it looks like.
Notice that I didn't combine these either because they're not like terms. You cannot tell me 5 minus 2 is 3 radical 3. That's like saying 5 minus 2x. Not like terms.
Yeah. Okay. All right.
Okay. You try the rest.
Let me give you a little hint. Remember what it means to square something. I just happened to see that one. Remember what it means to square something. Y'all want to like square each term. Remember that squaring something means multiplying it by itself. So watch Ms. Dell. She's going to give you a little hint. Just write that out twice. And then you're going to use FOIL. Some of y'all use double distributing, but most of you all go to FOIL.
Both are the same.
Ask us if you got any questions.
Okay.